In this question, we were asked for a group frequency distribution table. And the reason for that is if we scan through, we look at for the lowest score, and what we find is that lowest score is 16. And if we scan through and we look for the highest score, we got 64. And so the range is too much. It's too much for a regular distribution table, because we'd have, well, let's see, if the top one is 64 and the bottom is 16, 64 minus 16 is 48. And so if every number had its own row, then we'd have 48 rows. And we really wouldn't see much of a pattern in that, because most of the numbers don't repeat. And so we wouldn't really see the pattern in our data as clearly as we will when we have the grouped frequency distribution. So we need to go from 16 up to 64. And what we want are intervals of equal width. And we need to have about 10 of them. And we want those intervals to be a simple number. What is meant by simple is a number that's like 2 or 5 or 10, not 3 or 7 or something like that. If we use intervals of 2, we're still going to have a lot. 48 divided by 2 is 24. So we're still going to have too many intervals. The next of the simple intervals is 5. And if we have intervals of 5, we'll be good to go. So that's the width that we're going to use on our x's. And the last of the rules for creating a grouped frequency distribution is that the bottom of the interval needs to be a multiple of the width. If our width is 5, then the bottom needs to either be on the 10s or on the 5s. So 5, 10, 15, 20, etc. We don't have to go down to 5 or even 10 because our lowest score is 16. So the bottom interval is going to be 15 through 19. And we'll see how far down. Let's see. If I start it about here, I should have enough space. So 15 to 19, 20 to 24, 25 to 29. And that's because, 15, 16, 17, 18, 19, right? And yes, I do count on my fingers. That's just how it goes, right? So 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So these intervals are a width of 5. It just feels weird with that ending point sometimes. And sure enough, I didn't give myself enough space. So what I'm going to do, sorry for the shaking, rather than restart. So the numbers there were 64 minus 16 was equal to 48. So I just need that one more row. My top score is 64. So I just need 60 to 64. So I can just bump it all up. And now what I'm going to do is I'm going to put those 30 scores in. 17 goes down here. Right? 24, 22, 32, 30, 21, 44, 25, 45, 34, 36, 28. All I'm doing is I'm reading them right off of that question. So if you want, you can stop the video, scroll back to where you're seeing the question and fill in your frequency table along with me. 20, 38, 16, 22, 39, 22, 56, 51, 53, 29, 20, 26, 28, 64, 23, 43, 19, 58. I'm going to translate these into actual numbers. So 1, 2, 2, 1, 2, 3, 3, 5, 8, 3. I'm going to double check that I did this right. So if I add up all of these, the question told me I had 30 scores. So if I add up all of these numbers, I should get 30. So 1 plus 2 plus 2 plus 1 plus 2 plus 3 plus 3 plus 5 plus 8 plus 3, and I get 30. So the sum of the frequencies equals 30, which is N, so we're good to go. The next part, so the question said the following scores are for for a random sample of 30 drivers who were issued speeding tickets in New York during 2008. We had to determine the best interval and create our frequency distribution table. And then from looking at your table, does it appear that tickets are issued equally across the age groups? And no, it doesn't, because look, there are many more scores in the younger age groups than in the older age groups. So I would say no, it appears that more tickets are issued to younger drivers. So be sure to look at the whole question and answer all of it, not just create the frequency distribution. There may be something else that you need to do.